Now that we're full and sleepy, let's talk air again, right? That's exciting. Okay, so for those who were not here for the first panel, my name again is Gutierrez. I'm a partner at Hogan Lovells, and I do a lot of air quality work for the Air Quality Control Commission here in Colorado. So for the first panel, we heard from Robin and Gordon talk about the division's program and how it's doing monitoring out there in the field. What we're going to hear on this second panel is from two operators as well as a perspective from a consultant that works on behalf of local governments with respect to their implementation of their programs that are required to comply with the program we just heard about from the division. So we have with us Brent Buck. Brent is CEO of Ajax Analytics and a thought leader in innovative methods for monitoring. We're going to go back to our fun facts too. Brent's fun fact is that he once wrestled a 6-foot crocodile. He's fine, but I hear the crocodile lost a tooth in the battle. So we also have with us Kathy Steerman. Kathy has an impressive 25 years of experience advising and managing air quality compliance programs, including related to monitoring. Kathy's fun fact is that she worked in Beirut, Lebanon for 2 years, and there she established the first environmental lab to ever pass blind certification in a Middle Eastern country. Very cool. And last but not least, we have Jerry Dismukes. Jerry's the air compliance lead for Caerus operating. His responsibilities include development of the monitoring programs that are required to come into compliance with the Air Division's program that we just talked about. Jerry's fun fact is that he has run 10 marathons, and Philadelphia and Leadville being his favorites to date. So with that, I'm going to pass it off to Brent, and please jot down some questions as we're working through this. We're going to leave some time for Q&A, and we can ask this panel about their different programs.
Thank you, Anna. While we pull up slides, I'll preview. I have 8 minutes to go, so I'm going to stick to the script, which means I'll read a little bit. So Ajax Analytics pioneered some new methods of air monitoring and has provided air monitoring as a subscription service since 2017 to communities, landowners, and oil and gas operators. In the next few minutes, I'll be sharing some of my key principles and some important concepts of an air monitoring program. My goal today is to help you create a mental framework for how to think about air monitoring at your company or in your community. I like to frame air monitoring as a spectrum. On one end, we have no knowledge whatsoever about what's in the air that we're breathing. On the other end of the spectrum, we have our ideal perfect knowledge state where we have Star Trek-like understanding of every compound in every cubic meter of space during every second of every day. Air monitoring is our attempt to move our level of knowledge from one end of this spectrum to the other. To move down this path, we use real-world measurement from various technologies, each with varying levels of certainty, and then we extend that measurement with assumptions or modeling. The overall goal of any scientific endeavor is to maximize measurement and minimize assumptions that we need in order to have enough confidence to make a decision, take an action, or communicate on a topic. We make air monitoring better by improving on 3 key principles for air monitoring data: time resolution, spatial resolution, and data quality. All 3 work together in order to deliver a useful measurement. Of course, the hard part is to maximize all 3 legs of this triangle while keeping costs low and reasonable, and while avoiding having any one leg be so short that our assumptions have to stretch really, really, really far in order for us to make a decision. So here's an example of what kind of actionable knowledge high-resolution monitoring can provide near an oil and gas pad. In this real-world data example from one of our programs, we see continuous 1-week average total VOC data from a reference grade sample on top. On the bottom, we have PID, or volatile organic compound indicator data, from a PID sensor at 1-minute resolution and grouped by day. So the excellent data quality and the middling time resolution of the 1-week data show us that for 5 weeks, total VOC jumped from a normal baseline at this site to peak at about 10 times that normal baseline. The 1-minute PID sensor data has much more uncertainty in the data quality lag. It doesn't tell us as much, but the technology provides incredible time resolution. So when we combine these data, we can really start to understand what was driving those real-world weekly increases in VOC. And together, this data shows us that the increased weekly measurements at this site were actually only driven by about 200 total minutes of observed emissions within that 5-week period. So 200 minutes drove the whole increase, which is how we can leverage technology synergies to extend out the concepts of time resolution and data quality even further. So in our case, we use automatically triggered canister samples when TVOC indicator increases. So something's going on, trigger a canister sample. With this level of time resolution and reference quality data in those moments that matter, we move from assumptions about what's driving the pollutant increases to actually measuring those actions that are driving the pollutant increases. So this ability gives us incredible perspective. We measured 1 minute total VOC at nearly 500 times the baseline at this site from a few weeks earlier. And we've seen 1 minute changes up to 40,000 times baseline. So while this gives us great information about the level of pollutants directly in the path of an emissions plume, it also suggests that this site wasn't exposed to 70 parts per billion of VOC for the entire week. We can now justifiably assume that this site experienced 7 to 8 parts per billion for most of the week and had a few distinct moments with much, much higher pollutant levels, which leads to this particular pad site isn't steadily emitting pollutants, but some specific activity produced a high rate of emissions for a very short period of time. So the synergy of different technologies creates an opportunity to level up that data quality lag without exorbitant cost increase. Tools like wind and composition analysis then can help determine exactly what activities were causing emissions from the nearby oil and gas pad or something else in the community, and hopefully leads to just simple corrective action. Let's see, there we go. So the real power starts to show when we add in the third leg of the data usefulness triangle. This video shows a number of TVOC indicator sensors across about 15 square miles there. So I've highlighted the one oil and gas pad site that we reviewed on the previous slide during this same time period. What we probably note first is the strong visualization of that previous point about rapid change in real-world pollutants on a short-term basis. This graphic is visualizing 1 hour average data, and it looks even crazier when we do this with our 1 minute data. We also start to intuitively see a pattern where certain sites seem to have a much more localized VOC influence, and others are reacting to larger regional VOC changes. With all 3 monitoring principles optimized, the larger spatial program gives us some very important perspective. We saw when we optimized time resolution and data quality at one site, we clearly had some opportunities to reduce emissions and activities at that site. However, spatial perspective starts to show us that there are other areas or other activities that may provide an even higher environmental return on investment for our time investigating and problem solving. So that's a brief summary of my basic principles for how to address the challenges inherent in air quality monitoring data. Regardless of how we each choose to address those challenges, I think everyone's end goal is to sift through all this uncertainty to enable data-driven conversations that can ultimately lead to finding and prioritizing those simple changes that can generate a high environmental ROI. So whether your need is to respond to a laundry list of concerned citizen complaints, report to an activist investor, or make changes to protect public health and safety, those problems always become much easier to solve once they're well understood and well defined, which is ultimately why air monitoring becomes so important. With that, my time is up, and I look forward to the panel discussion. Next.
Okay, thank you. And thanks you guys for all being here today. I'm feeling very sentimental about all the work I've done out on the Western Slope. I'm just glad to be back out here. My name is Steerman. I'm the manager of air compliance and engineering for Civitas. And just a little bit about our company. We were recently formed by the merger of 3 companies that operate in the DJ. And all 3 of those legacy companies approached air monitoring just a little bit differently.
You're back on.
And we were using different vendors and different types of sensors. So we're just now bringing all those programs together. So today I'm going to talk just a little bit about how Civitas is doing air monitoring. I'm going to talk a little bit about the challenges of the program and really where we want to be as a company with these programs in the future. So in early 2020, we knew an air monitoring regulation was coming for the upstream oil and gas industry. So you can see in this photograph, Extraction, one of our legacy companies, began testing some of the more mainstream continuous VOC and methane monitors. We wanted to know if there were any that stood out as clear winners. Did they have power issues? How did their data platforms work? And were they portable? And I can summarize by saying that they all did work well, and they all still work well. So the technology has not been a challenge to implementing this program, but I did want to talk a little bit about some of the challenges that we do face. By far and away, it is staying ahead of the drilling schedule. We do have to have our plans in 60 days ahead. We have to have monitors out 10 days before. And our drill schedule is 2 years out, but if we don't have drilling permits issued, those plans can leapfrog. And even with the best of communication within a company, sometimes we are surprised. The other thing that's been a little bit of a challenge is land use. We need to use some cooperation from landowners to site sensors. Sometimes that works for the winter, but they might need to, for example, mow in the summer. We may put one on our own pad and find out it's in the way of something, so we have to move them. Another challenge has been just communication within the company and with local governments like yourself. We talk a lot about the data within the company, and we communicate with local governments. So yes, that's been a big challenge. The other one's been the monitoring plans. We have quite a few. They're all quite unique, and depending on alert levels and things like that, I would say that as an executor of the program, they're wildly different. So we're going to talk a little bit about Civitas' program. I think Gordon said there's 131 monitoring plans. Civitas has 27 of them. So if we have 27 plans filed now, if I look at our drilling schedule, we expect by the end of next year we'll have over 50 monitoring plans filed with the Air Pollution Control Division. So this slide talks, transfers from plans to reporting. So if we have 27 plans, we are filing 27 reports a month. We'll probably by the end of next year, we will have filed over 900 monitoring reports with the Air Pollution Control Division. This is a slide that kind of depicts, it's taken with a drone. It's a drilling facility, a drilling site, and it really shows the synergy between an operator's program and a local government's program. The sensors here that say AeroQual are deployed and operated by Civitas or Extraction's third-party consultant, and the other sensors in here are part of Broomfield's local government program. And looking at this slide, it's a different pad. This is the hydraulic fracturing phase. But what I want to say about this synergy is that all of this data is publicly available to anyone who wants to take a look at it and make comparisons between the programs. So Civitas is a large company. I've been talking about what I call our compliance plans. I'm going to move more into what I'm calling our voluntary programs. We have assets that are very, very urban and very, very remote. So there's a lot of opportunity for us. In the past, Crestone and Extraction have worked with CTEH to deploy scientists into the community to make real-time measurements based on human observation. That has given us some great perspective on how our potential emissions move into communities. Extraction has deployed passive sorbent tubes at the fence line at some of our sites, and we continue to do so because we find that data at least somewhat translatable to the ASTDR guideline for public health exposure. Extraction and Bonanza have participated in flyover campaigns with partners like Caerus Aerospace and Bridger Photonics to see what we can see from the air. And we've learned an awful lot about what is really meaningful in that broad sense, which is that you really still want to find the big leaks. And then we're comparing apples to oranges by overlaying some of these technologies at some sites. We're also doing a couple of exciting things on horizontal pads right now, too. Long Path Technologies is working with us on a few sites in Weld County to measure emissions. This is a technology that is mounted at the center of the pad. It's mounted on a tower. We affectionately call it the Eye of Sauron. It moves throughout quadrants of our facility and helps focus on emission quadrants, and it'll alert us if anything is out of the ordinary. So this really helps us focus our leak programs. We're also working with a company called Clean Connect on 7 other well sites in Colorado. Clean Connect uses continuous optical gas imaging, and this is also mounted at the center of a pad. It rotates throughout our system, and it measures leaks. But what's cool about it is it's building and building and building artificial intelligence to inform leak concentration and make that better. The other thing Clean Connect can do for us, which is important, is it takes on other non-emission things for, that an optical gas camera can do, like tank level measurements. It can tell us if there's a liquid spill. It can let us know if there's smoke on a site. So both of these systems can measure emissions and really help us focus our leak programs. So where are we going to be? I believe very soon, this is rapidly moving, we are going to have one solution and one installation that satisfies our air quality monitoring programs and our leak detection programs with one installation. And it still hopefully retain that flexibility that is so important to local governments and to all stakeholders to be able to deploy these programs. So I think this is going to be a year where we focus our our AIM programs, meaning one solution satisfies both. I'm going to hand it to you, Jerry, my friend.
Is this thing on? Hello?
Top one.
Is it on? Can't even tell.
I think it is on.
Sorry. My name is Jerry Dismukes. I'm the air compliance lead for Caerus. And as Bob mentioned in the previous discussion there, that we're a West Slope operator. We're a little different from Kathy's company in that we basically drill for gas and we have associated liquids. So it's a little different perspective from some of the DJ operators. I may have to refer to my slides because I'm basically blind, but basically I'm going to go over some of what we do from a VOC monitoring perspective in terms of what we've done historically, what we're doing now, and also I'm going to touch briefly on our optical gas imaging program as well. So we at Caerus, which was obviously previously, we basically have been a conglomeration of a variety of smaller companies over the last 7 or 8 years. We've been doing OGI FLIR camera inspections since 2014. And then recently, early 2020, we partnered with CTEH to do an air monitoring study on one of our basically pre-production pads. So a Symposium pad where we're drilling hydraulic fracturing and flowback operations. And as well, we also do, we monitor for total VOCs at 2 well pads currently and one dedicated flowback facility. We've also done pilot studies in early 2021 looking at some of the same technologies that Kathy mentioned, Bridger Photonics, GHGSat, and some others. And we've also completed some surveys across the border in Utah, where we also operate, but we're also going to be completing an aerial methane survey later this year in the Piceance Basin. So to touch on the air monitoring study we did in early 2020, this was really driven by in-house. Basically, we wanted to see what are we seeing with our worst case emissions scenario, which for us we felt was during pre-production activities, SIMOPS, you're drilling, flowing back, and completing wells all at the same time, essentially. So we did a study in early, I think it was January 2020, and we looked at VOCs, various HAPs, including benzene, toluene, hexanes, and we basically did a combination of worker badge sampling, so 8-hour samples, 15-minute samples. We did SUMA canisters on some of the fence line areas, and we also did handheld real-time air monitoring. So all in all, we pulled over 1,000 readings during that study. And the highest handheld reading we saw, not surprisingly, was on top of one of our flowback tanks. I think I was actually there that day when it happened. And just, I guess the crux of that study is that the vast majority of the worker badge readings were all non-detects. There were some low ratings that were found, but all of them were below health level critical health level standards and concerns. This is just a snapshot of the facilities where we did this study. Again, this is basically on the border of Garfield, Rio Blanco County, up around 8,000 feet. Essentially, we're 10 miles from the nearest residence, so we're really not impacting the public per se. So we did the study basically to see how we might be impacting our workers on location. So from that study, some of the lessons learned. Basically, all the monitoring that was done was basically on the fence line or inside the fence line, because as soon as you go off of our pads, you're essentially dropping off into like valleys, and it's in pretty extreme terrain out there. The majority of our detected readings were on the L27, which was where we had active flowback ongoing. This was basically, what came out of this study was basically this was the last pad where we used traditional flowback tanks or open top tanks. What happened next was basically we decided to go to a dedicated flowback facility, closed loop flowback facility, which is now required in Colorado, but we did this basically ahead of the game, and we stopped using the open top flowback tanks, and then we went to what's called three-phase gathering on all of our well pads. So basically it does away with the need for production tanks and control devices on your well pads. You route everything downstream to a centralized pad. Then along came May 1st, 2021. So Reg 7, this is the VOC monitoring, like what Kathy was talking about with our monitoring plans. So as of May 1, 2021, we are required to do monitoring on all new well pads and also on satellite facilities, which for us are where we route our fluids to handle or process flowback liquids. So Caerus first deployed VOC monitors in June 2021 at 2 facilities, and we chose to monitor for total VOCs as opposed to methane or benzene. You kind of work that out with the division in your submitted plans. And for us, we set 2 alarm thresholds, which basically are initial response event and then a secondary response event. We set them at 10 ppm total VOC and 20 ppm total VOC. This is basically just showing where we put the monitors. So this is our flowback facility. You'll see a little, we're using canary monitors. We basically triangulate our monitors around the pad. So where we're doing our monitoring, we put 3 monitors and basically triangulate around all the activities. This was our flowback facility. The next one is actually our first well pad, where we had a handful of wells we drilled there. You maybe can't see them, but the little yellow buttons there are where we place the monitors. What you're seeing here is the dashboard. So I unfortunately look at this every day. I looked at it last night when I got home from some adult beverages, just to like see what's going on in our facilities. And it's actually been really pretty useful for, not necessarily for public receptors, of course, because we're essentially in the middle of nowhere. Like I said, 10 miles from any public receptors. But what is the issue out there for us has been, versus the DJ, is connectivity. So we really had a harsh reality when we first went out to put out all these monitors. None of them worked. We had 0 connectivity, and they're like, well, we basically had to go out and have them put on the little boosters and upgrade the connectivity so that we could actually get the data. So that took about 2 or 3 weeks initially. Now we've kind of figured out those connectivity issues, but other issues that I didn't really foresee happening are we've had sensors blown over. I mean, we're basically at 8,000 feet on some ridge line in the middle of nowhere, and I'm pretty sure if they didn't blow over 2 nights ago, I'd be pretty surprised. But we've had several sensors blown over on our J14 pad, and as a result, we had to move one of those from off the facility fence line because it kept getting blown over down onto the pad. And so what you're seeing, if you can see it, well, I can barely see it, but right, you see the numbers there. The G35 is our pad, basically our current drill pad, where we have nothing really going on. The J14 is where you'll see some colored numbers there, some yellows and oranges. And those aren't necessarily things to worry about, but it just says you're above background. And then the Wolf Ranch facility you'll see below there is our flowback facility. So I can look at all of these in one kind of snapshot and see what's going on. This here is just another screen that I look at essentially. You can see on the right a small blip a small blip in I think our monitor on the southeast side of the facility. The lower part of the graph there you can see wind speed and direction. So basically within 2 months I knew what was going on at any time at this facility because I know where the wind sensor is, I know where our equipment is, and I know where the monitors are. So this here, I want to just kind of, maybe you can't see it, but I know I can't. But we have a handful of IREs, which is our initial response action levels. We've had 10 of them or so at Wolf Ranch, and they all occurred last summer. And then on the J14, keep in mind we've been monitoring these since last July. We saw nothing on the J14 above any IRE levels until March of this year. And I'm going to discuss in the next few slides as to why that was. So the monitoring at Wolf Ranch, we essentially use this data along with our monthly IR camera inspections to make changes to that facility. Wolf Ranch was our first flowback facility, or is our first flowback facility. And we were seeing some higher readings on some of the sensors near the tanks. And so basically what we did was we did a couple different pilot projects. One last July, we replaced some of the thief hatches with a lockdown style thief hatch, and we saw immediate results as soon as we did that. I'll show on the next slide here actually. So the graph you see there, you can see the day we actually replaced those thief hatches with the lockdown style, it basically doubled our flow rate to the combustor. And you can do the math. That basically says that we were likely not venting back in the tanks. So that was an immediate thing we realized that was going to help our facility. I think back here again. And then more recently, we replaced the existing combustor out there with 2 higher volume combustors and better automation and flow metering, and it's really just dialed in our facility. So basically what I'm getting at is that we use, while we're not having any sort of impact on the public per se, we've still used that data we're collecting to basically engineer that facility and redesign it such that we know we're capturing everything as most effectively and efficiently as possible. So this is the J14 pad. This is where we had the wind blow over the sensor a few times. And one day I was looking at the results on our canary screen, and I saw that we were getting some numbers, and we hadn't seen anything above 1 ppm since we started monitoring in July. And I realized, I'm like, what's going on? And they said, oh, we moved the sensor down from the fence line. I'm like, okay, well, you'll see here, the canary's on the left there, circled in red, and there's a blowdown tank on site, so occasionally we have to blow down wells if we get liquids in the well. And the blowdown tank you'll see is about 25 feet away from the canary unit. So that sensor location is not representative of a fence line measurement. That said, we've moved it a little further west, but that's kind of why we've been seeing in the last month a lot of higher levels. Nothing above anything of significance, nothing above where we have to report anything to the state. But I know exactly when we're blowing down wells, and I can tell exactly what's happening with that facility. I wanted to touch on our LDAR program just because it's really, it's not monitoring per se, but really is monitoring because we're looking for leaks and fixing them in real time. So in 2021, Caerus documented about over 1,000 OGI inspections in the Piceance at 658 facilities. About half of those were voluntary inspections, and those voluntary inspections will be going away starting next year because they're going to be required everywhere on a much more frequent basis. We found and fixed, our LDAR guys found and fixed 900 total leaks or so in 2021, and we only have maybe 1.5 full-time LDAR people. And I think my point here is that it's really critical to have certified people that can find and fix leaks. When I started at Caerus, I was going out with a FLIR camera, and I can't fix any. And it was pretty much just a pain for the operators. So as of this past year, we had over 80% find and fix on our leaks, whereas in 2018, it was less than 40%, which is really inefficient and causes operations to really hate you because you're sending out work orders nonstop. 2021 also saw our first LDAR-driven retrofit program. So we've been able to use our LDAR data, and we report all this to the state. So it's all this data is going to the state anyway. But we basically found a certain style of our pneumatics where we were seeing chronic issues with it. And so based on our LDAR results, we basically have gone to a large retrofit program around that style of pneumatic, and it's dramatically increased basically our lack of leaks now. So path forward, Caerus we're going to be deploying additional TVOC monitors at 2 additional facilities this year, another well pad and another flowback facility. We're going to do aerial methane surveys across all of our assets this year. We're hoping to do in-house drone surveys if we can get one of our guys trained up, because we do have a drone with OGI technology on it. And we're going to be staffing up for a massive increase in LDAR that's going to be required in Colorado starting January 1. And applying what we've learned through LDAR to drive equipment upgrades. So we don't just use our LDAR and our surveys to check a box. We use it to try to dial in our programs and make our equipment more effective. So that's all I have.
Awesome. Well, I have a few questions for them, and then I'm going to open it up to you guys. But Jerry, let's start with you since you have the baton, if you will. So you noted that you see alarms or triggers through your monitoring system, and those come to you or somebody in your company. How does the company react, or what do you do when you receive those pings?
So when I receive something over the 10 ppm threshold, I basically email or call our LDAR guy and the guy who works at the facility. So it's usually our flowback hands. And so I'll ask them, hey, what's going on? And truthfully at this point, I know exactly what's going on because I've dealt with so many of them. But in the beginning, we would have our LDAR guy go out and check out what's going on. And that's really how we respond to that. So it's usually within 24 hours we address it. So
good. And then both Kathy and Jerry, you both mentioned aerial. The state mentioned aerial. There's $7 million coming to the division for focusing on aerial studies. Can you just talk a little bit more about your flyover studies, the data, what actions you're pursuing around that?
Sure. I'll start with that. We did some in Utah last year, and we've had a couple of pilot ones done in the Piceance as well. And I can definitely say that the data is useful. It's definitely helped us in terms of we have found issues on pipelines. But another thing that we didn't really expect was we paid for some flyovers, and more than half of the leaks found were on other operators' stuff. So I think what I'm learning is that there's definitely some value in teaming up with other operators and sharing information, because it's just the right thing to do. So if someone does a flyover, I've been emailed by them, the company doing the flyover, to say, hey, we saw something over here, you might want to go check it out. And it's proven to be pretty effective. So
that's great. And you, Kathy?
Yeah, I would second that, the communication between operators, but the communication also between the flyover teams and the operator to inform what they saw. One of our experiences was we were doing a chemical treatment on wells, and the foam from the chemical treatment held a dump valve open. So the flyover caught a maintenance event, but it's just an example of what you can see.
That's great. And then Brent, since you're sort of in the world of innovation of these technologies, I guess my question to you is, what do you see as one of the most significant challenges as we continue to develop and deploy new technologies?
So I think the next thing that everybody's going to have to deal with is the data, right?
Yeah.
So Kathy mentioned in a couple of years there'll be 900 reports to the state every month. Both of these operators mentioned multiple technologies, each with their own dashboard, each with their own flavor of data, right? Is the name of the time field time, or timestamp, or start date, or whatever. There's going to have to be, at some point, pressure to get all of that data in a consolidated format, so that it can be compared without an army of $100,000 a year data engineers pulling it all together manually. So I think the next big leap in this, once we get through the quick, easy ROI fixes, is going to be, okay, how do we pull this together and start assessing one technology versus another, or one drilling style versus another, one SOP versus another, based on this comprehensive data set from the last couple of years of continuous monitoring.
But presumably with so many data points, it's a real challenge even to summarize a week's worth of data, let alone years and years, and then comparing that to different operations.
Yeah, we're moving into
Yeah.
the realm of what currently is sadly done by marketing for knowing what you searched on Google last week. That level of data organization that Facebook or Google or marketing companies do to pull data together and really tell the story. I think this has a lot more value than that, and I look forward to that kind of transition.
Very good. With that, I'd love to hear questions from the audience. What do you guys want to know about these monitoring programs, results, actions? I think there's a question in the back there. Do we have a mic?
Good afternoon, Deborah Caden, Ramble. A lot of the operators are collecting real-time VOC data, minute by minute data. What does that tell you, as opposed to having actual data about maybe longer-term averages, but actual concentrations of individual VOCs?
I'll take that one. This is, I think, the hardest part of this transition from traditional science, where reliable data was kind of the only thing you had available, to some of these lower cost sensors that give you 1 minute indicator level data. And it's super important for everybody using these systems or looking at this data to understand is these smaller sensors that are proving so valuable don't tell you anything more than something changed, right? You can, even if it presents its data as 3 parts per million or 5 parts per million, what it really means is there's a baseline and there's a change from that baseline, and you should probably go check it out. Translating that into actual concentrations or actual levels of emissions or tonnage per year isn't something scientists have really nailed yet. I mean, we're working on it, and hopefully we get there one day, but it's not there. So you have to remember, it's just something changed, go check it out.
Another question right there in the back.
Can you hear me? Yeah.
Yes.
Hi, Eric Kodak from Ramble. So you had some great graphics up there regarding point data and intensity. And you mentioned meteorological sensors. How are you doing source apportionment or source culpability, or are you doing that?
So personally, Ajax Analytics, we don't stretch any further than event by event. So something happened, look at the wind data from that moment, and with as much certainty as we can, and caveating all the way, we think this came from the south. The pad is 300 feet to the south. Therefore, most likely this event came from the pad site. I'm sure we've been wrong at some points. I'm sure we've been right more often. Source apportionment overall from, say, like more laboratory grade analysis is something that university researchers are working on, trying to say, okay, if we measure 5 or 10 parts per billion of total VOC, how can we, with some assurance, say 2 parts per billion is kind of just general, came in on the wind from Utah, 2 parts per billion is more related to traffic and urban, and 3 parts per billion is associated with oil and gas. That, I don't think, has been truly figured out yet, but people are working on that apportionment kind of model.
Let me add a little bit to that, Eric. Thanks for the question. So in our quadrant monitoring, I think what we are going to be able to do eventually, once we have this data, is look at source apportionment. For example, if you're looking at a list of wells in that quadrant that are instrument air actuated, and then that quadrant goes back over to wells that are natural gas actuated. As that data builds, we're going to be able to look at those as different kind of segments and start to build that data and see how they compare. You'll be able to make a determination about whether or not you have a certain type of maintenance control on your unloading, for example. So those sources will start to kind of probably build data as time goes on.
Yeah, I'll chime in as well. We're not doing any source apportionment per se, but just from all the data we've been seeing, we see a background of like 0.3 parts per million. And what it's gotten to now with our facilities engineers, they'll be like, hey, send me a snapshot, what happened at Wolf Ranch last night? And if it's anything above background, they take personal affront to it, truthfully. And he's like, it's really helped us, like, me and the engineers, like, better design some of these facilities. And it's really been, from that aspect, it's been really useful and an interesting project for us the last 10 months, basically. So.
Other questions?
Okay.
All right.
All right.
Thank you all. Let's have a round of applause for our panelists.
Yeah.